This miracle was achieved using a cutting-edge device on the Southern Astrophysical Research Telescope. Researchers have managed to count these tiny but incredibly significant particles of light using CCD technology. This is a revolutionary step in the fields of astrophysics and cosmology. On June 16th, at the Astronomical Telescopes Plus Instrumentation meeting of the Society of Photo-Optical Instrumentation Engineers in Japan, physics PhD candidate Edgar Marufo Villalpando presented these extraordinary results. Villalpando, a brilliant student from the University of Chicago and a Fermilab DOE Graduate Instrumentation Research Awardee, delivered a presentation that rocked the scientific world. CCDs were invented in 1969 and earned scientists the Nobel Prize in Physics 40 years later. These devices consist of light-sensitive pixels that convert incoming light into electrons, and they have been indispensable for astronomical observations. However, Skipper CCDs are changing the game entirely. This new technology allows us to count individual photons with unprecedented precision, pioneered for dark matter experiments like Sensei and Oscara in 2017. Skipper CCDs are now being used for astronomical observations as well. In March and April, researchers collected spectra from galaxy clusters, distant quasars, and stars potentially related to dark matter using Skipper CCDs on the SOAR integral field spectrograph. These observations, capable of counting individual photons, have revolutionized the field. For the first time in astrophysical CCD observations, researchers achieved subelectron read noise and counted individual photons at optical wavelengths. As Marufo Villalpando noted, the amazing thing is that these photons have traveled from objects billions of light years away to reach our detectors, and we can measure each one individually. This technology is being used for the first time to observe the night sky and gather astronomical data. Fermilab and Lawrence Berkeley National Laboratory are developing new generation Skipper CCDs that are 16 times faster than current devices. These devices will be used in future cosmology projects, NASA's upcoming Habitable Worlds Observatory, and many other areas. These advancements signify giant leaps toward uncovering the secrets of the universe. In conclusion, this new technology is set to revolutionize astrophysics and cosmology. Skipper CCDs will allow us to gain deeper insights into dark matter and dark energy. Be part of this incredible journey by subscribing to our channel and liking our videos.